This video is about your course project on the theme End-to-End Encrypted Chat Web Application. We understand that nowadays web applications are the most common forms of applications, and essentially your browsers become the most common native application to run on a computer. You need to learn about how to secure web services. On top of that, we're also interested in privacy of communications. How do you privately communicate with your friends? In this project, your job is to implement an end-to-end encrypted chat web application and secure various aspects of the website. The following are the main objectives of this project. First, you will be given a basic chat web application, and you will need to make it secure and end-to-end encrypted as well. For that, you will first comply with some of the requirements of the NIST publication on digital identity guidelines regarding authentication and lifecycle management, which we've already talked about in class, which is normally targeted at US federal agencies, but is also a reference for other types of systems. I will detail in the next slides what are those requirements. As part of that, you will also implement a secure multi-factor authentication mechanism based on passwords and one-time passwords. You will then need to encrypt communications between two users of the chat so that the server does not know the content of the messages. We call that end-to-end encryption, the ends being the users. You will need to protect communications in transit by configuring a modern TLS deployment. That means the connection between a user and the server needs to be protected using TLS. And finally, you'll package your application in a Docker image. You will also be given a Docker image of a basic chat application. Requirements include the following. So those are the requirements regarding the authentications of users. So following the NIST's publication, you will need to comply with all the requirements written in that publication when it is written that you shall do something or you should do something. All the requirements that include may are not to be done in this project. You will comply with such requirements in the sections that are listed below, not the entire guidelines. For example, for the use of authenticators, you will need to choose user-chosen memorized secret, which is our common password or passphrases, together with a single-factor one-time pad device, which is, for example, your Google Authenticator or other authenticator apps on a phone. If you do have, some of you have, a single-factor cryptographic device, for example, a YubiKey or equivalent, you may use that as part of your project. Okay, that is not mandatory, but if you have and if you want, you may replace the OTP device by a cryptographic device. And third, you will need to use lookup secrets, which are essentially recovery keys in case you lose your OTP device. Okay, so three different factors, two of them the memorized secret and either the OTP device or the lookup secrets are used during login. You will need to comply with the related requirements of those types of authenticators that are listed in section 5.1 and section 4.2.2. Note that within section 5.1.1.2 it is written memorized secrets, so passwords, shall be salted and hashed using a suitable one-way key derivation function. So because it's a shall, you need to follow these requirements. It is listed some of the recommendations that you may follow. I would make you look at our password security lecture for choosing an appropriate function. Still within the same section, it is also advised that passwords obtained from previous breach corpuses be used in order to verify that passwords are not weak. You should implement this mechanism, and you should refer to the given API over here for the corpus of weak passwords to check against. It's essentially a list of leaked passwords that have been leaked and collected on the website haveabeenpwned.com, which we discussed in class. Section 528 and 529 will be automatically complied based on the rest that we've done so far. You will also need to comply with section 522, implement rate limiting mechanisms. For example, users should not be allowed to try too many times to log in. And you should also implement image-based CAPTCHAs. You need to implement new account registrations and bind authenticators at the same time. So during account registration, users need to set a password, they need to bind their OTP or cryptographic device, and also obtain recovery keys. All of that need to be done during the registration process. Optionally, in order to make the application more realistic, you may want to provide a way to change the authenticators after the account registration. So once an account is registered, a user may want to change their authenticator. You may implement that. Section 7.1, implement proper session binding requirements. This section lists a number of things that you need to do in order to properly bind the session. There is one exception in the sections that I mentioned regarding the OTP authenticators. It is written in the NIST guidelines that particularly for software-based OTP generators, it should be discouraged and it shall not facilitate the cloning of the secret key on multiple devices. The Google Authenticator does not comply with this requirement. However, for the purpose of this project, this is fine. So Google Authenticator, Microsoft Authenticators, or other similar 2FA app on your phone are okay to use. But if we wanted to strictly follow the guidelines, that would not satisfy the guidelines. All right, so those are the requirements regarding authentication. Next, you have a list of requirements about the end-to-end encrypted chat. Once users are logged in, you should secure chat messages between two users in a way so that the server cannot decrypt the messages. You should use elliptic curve Diffie-Hellman key exchange protocol to establish a shared secret between two users. In order to do that, you should leverage the Web Crypto API, which is an API accessible on modern browsers. Okay, you don't need to import anything, it is given to you by the browser. I included a demo link over there that demonstrates how to do that. The link Web Crypto API gives you access to the documentation on this API. The information exchanged during the key exchange can be sent through the server. So as part of the key exchange, user 1 and user 2 need to send each other some information. You will do that through the server. We will consider that the server is trusted not to modify messages of the key exchange. We discuss what happens in Diffie-Hellman if the parameters, the public keys, are not authenticated. So in that case, we will assume that the server does not misbehave or the server is not malicious to change those keys. All right, in practice, that may be done differently. You should choose P384 as the underlying curve for the key exchange. Second, once the key exchange is done, you essentially end up with a shared secret. Out of this shared secret, you should derive two 256-bit AES encryption keys as well as two 256-bit MAC keys. You will do this derivation using HKDF SHA-256. HKDF is a standard for doing key derivation. We're basically deriving a bunch of random data out of a seed. Okay, so the seed is going to be the shared secret, and you will need to unroll enough data to obtain the required material. So one of the encryption keys will be used to encrypt data coming from user 1 to user 2, while the second encryption key will be used to encrypt data coming from user 2 to user 1. Okay, so both users do not use the same key to send and receive messages. Using the Web Crypto API again, you will be able to use that HKDF function. It takes as an input a salt. The salt should be unique, so another key derivation in the future produces different keys. For instance, you should start the salt as a counter starting at 1. In the future, if you have to rederive new keys based on the same shared secret, you would increase the value of the salt. It takes another parameter which is called the info parameter. This is essentially the same thing as associated data in authenticated encryption. We're using some information over here which is also used for deriving the key. The info parameter should represent the current context. So whether we are deriving the keys for encrypting data between user 1 to user 2 or vice versa, or whether we are deriving MAC keys. Okay, so I gave you some examples of strings that can be used as an info parameter. Next, messages should be encrypted using AES in GCM mode. GCM mode actually takes a 96-bit initialization vector, and this initialization vector does not need to be unpredictable. Okay, we talked about the fact that IVs should be random. In GCM, the randomness is not a required property. However, IVs should be unique. They should be nonce, number used only once. So effectively using a random IV solves this problem with a small probability of collision. In our case, we will use counters as IVs. Okay, so the counters will represent the number of messages encrypted with the same key. Every time a user sends a message, it will be encrypted using a new IV, which is going to be the counter incremented. This IV needs to be sent together with the ciphertext to the recipient. As the recipient, you need to verify that the IV of a given message is greater than the IV of the previous message. This is used to prevent replay attacks. You want to protect IVs so that an attacker is not able to provide a chosen IV. So for that, we use a MAC. You should use HMAC SHA-256 on the IV. The associated data on the GCM mode, remember this is an authenticated encryption with associated data. The associated data should also reflect the current context. For example, encrypting a message between user 1 to user 2. The tags, the authentication tags from GCM should be 128 bits. That's the maximum size of the tag. You should store all key materials that you derived so far, encryption keys, MAC keys, in the HTML5 local storage of the browser, so that you can retrieve those after the browser is either refreshed or reopened. Okay, we don't want to lose those keys. And you should also store the shared secret. You should display the history of previous messages being exchanged plus the new messages. So this is already done for you in the small chat application that we give you. However, obviously the messages are exchanged in an insecure way. You will need to secure that, and you will need to decrypt messages with the proper keys. If the local storage has been cleared, then it means previous messages cannot be decrypted because we no longer have the right keys to decrypt them. You should display a warning. You should be able to detect that you do not have the appropriate key in order to decrypt those kinds of messages. Next, all symmetric keys and IVs should be rederived from the shared secrets when the user clicks on the refresh button on the chat. So that's not refreshing the web page, that's a refresh button within the chat application. We want to derive fresh keys out of the shared secret which has been exchanged previously. So for that, as I said before, you need to increment the value of the salt in the key derivation function and derive new keys and MAC keys. The participants that request a change should inform the other party with a special message that is composed of the last IV that has been used, the string change, altogether protected under the old MAC key and the new MAC key. All right? So a special message that contains last IV used together with the string change and protected with two MACs, one with the old MAC address, the MAC key, and the new MAC key, which is derived after the change of the keys. The other party should verify the old MAC before processing the message and derive new keys and verify again with the new MAC before accepting the new keys. Both parties should show a message keys changed in the chat history. So after this new derivation is done and the two chats update themselves to use new keys, we want to show to the user the fact that we've changed the keys. Old keys should be kept. You don't discard old keys because you need them to decrypt older messages when the browser is either refreshed or reopened. You should be able to identify which set of keys to use for a given message based on the preceding values sent during the key exchange. Okay, so if I refresh the page, you're going to get all the messages currently exchanged. That will include previous key exchange messages, previously encrypted messages, and so on. If you get a key exchange message, which we said should be a special message, you should check whether this message is older than a minute. If the message is older than a minute, that means it's not a new key exchange message being sent by the other party. That means you do not want to engage into a key exchange at that moment. Okay, you are just replaying, you're just rereading old messages. So you just look at the public key sent by the other user. You look at the public key that you had sent previously, and that should allow you to identify which set of encryption and MAC keys to use to decrypt following messages until, for example, there is a key change. Then, when the local storage is cleared, or when there is no shared secret for a given recipient, for example, you've never talked to another user, the user should initiate a defilement key exchange using that special message, and the recipient should engage in the key exchange even when there had been a shared secret previously established. Okay, so let's say one of the user has their browser cleared, their local storage is cleared. From the perspective of that browser, it's as if it never communicated with another user. Maybe it already had in the past, okay? So the user one is going to start a key exchange. The other user will receive a key exchange message and should comply with that. Chat messages should be encoded using UTF-8. So that's the encoding for the text. We only support basic text. We don't need to support rich kinds of text, only pure text. And network messages between users should be formatted in JSON. So JSON is a way to format data using your own schema. Okay, so for example, you could use, this is a JSON object, so curly brace type, colon, ECDH, together with key and a certain value. That could be one format of a message to give a public key to the other recipient. Another type of message would be type MSG, ciphertext some value, IV some value, and MAC some value. All right, so that would represent an encrypted message given the ciphertext, the corresponding IV, and the tag. All right, it depends whether the tag you want to separate it or whether that will be part of the ciphertext. You need to verify the details of the implementation. For all crypto operations, you need to use the console.log in order to log all those crypto operations. We want to see which key has been used, which IV, what is the plain text of the operations. It should be visually obvious, for example, that the IVs are not being reused if we send multiple messages. We should see that the keys have been changed whenever needed. All right. The chat application should be protected against cross-site request forgery, cross-site scripting, and SQL injection attacks. That means it should not be possible to send a message from a different website to another user. It should not be able, somebody should not be able to send to a user some payload that would be interpreted in the browser, etc., etc. Next set of requirements regard to the encryption of the communications in transit. That means communications sent between the user to the server. Communications should be encrypted in transit using the TLS protocol with the following configuration. You should reuse Mozilla's modern configuration for Nginx that is given at that website. It will give you a basic template for how to configure TLS for Nginx. Now, this is not enough for this project. We have the following constraints. We need to use TLS version 1.3 only. We do not care about older clients that don't support this version. We want to use the X25519 elliptic curve group, which is one of the possible elliptic curves that can be used in order to perform the Diffie-Hellman key exchange protocol as part of TLS. Okay, we want to use that specific elliptic curve. We need to use only one cipher suit. TLS proposes different cipher suits that can be used, including AES, for example. We don't want to use AES here, we want to use SHA-SHA-20. So this is the cipher suit that you need to use, that clients and servers will need to use. Mozilla's configuration will impose OCSP stapling. Given the type of certificate we will be using, you will not be able to use that, so remove OCSP stapling. We want to have an HSTS period for 1 week. That means browsers should remember to upgrade requests made to the website to HTTPS at least for a week. We do have a number of requirements on the TLS certificate. The TLS certificate should be an X509 version 3 certificate. It should include an ECDSA public key over the P384 curve. It should use the SHA-384 hashing algorithm as part of the signature. As a leaf certificate, it should obviously have the CA flag as false. The CA flag should be marked as critical. The key usage, another critical extension, should include digital signature only. The extended key usage should mention that the key is usable for server authentication only. The certificate should include both the subject key identifier, SKI, and the authority key identifier, AKI. The certificate should be valid for a period of only 90 days. Further than that, the domain that you will need to use for your certificate and where your website will be hosted is as follows. You will be able to use the domain group-your group number .comp3334.xavier2dc.fr. For example, if you're group 10, that means your domain is going to be group-10.comp3334.xavier2dc.fr. Essentially, all the subdomains for all possible groups will redirect to 127.0.0.1, that is your localhost IP address. Okay, so if you're hosting the website with your Docker container running on your own machine, you will be able to access the website using this domain name. All right, this is a domain name that will be resolved on the internet and that will always give you localhost IP address. So this is a convenient way for you to use kind of a seemingly legitimate domain name instead of just using a localhost. If you do not host your Docker container on your local host, if you have, for example, a virtual machine to make Docker work, or you're hosting that somewhere else, you will need to adjust your host file to point to the IP address where the domain is hosted. Okay, so I'll let you look into the documentation for your operating system. Those are the paths for the host files on Linux and Windows. If you are hosting your Docker container on localhost, as you can see on the right, resolving your group assigned domain name will give you 127.0.0.1. You should issue the certificate from the given CA certificate and private keys. We're going to give you a CA certificate and the corresponding private key. This is going to be the same for all the groups. You should use the CA certificate to issue a domain certificate for the proper domain name. The domain name should appear both as a common name and subject alternative name. Those are two locations where domain names appear. In the past, the common name was sufficient. Nowadays, we also need to include the domain name as a subject alternative name, or SAN. I'll give you an example of that in the next slide. The CA certificate is domain constrained to subdomains of my domain, meaning that you can safely trust it on your computer. Okay, you can import the CA certificate into your trusted store, and nobody else will be able to generate valid certificates for other domains than subdomains of this test domain. So this should be safe to trust the certificate for the duration of the project on your computer. This is an example of what the domain certificate that I want you to generate would look like. So for example, for group 0, if you deploy the Docker container with the chat application on localhost, and if you access, for example, group 0.COMP3334.xavier2dc.fr, you should be able to access the domain from here, and it should not give you any certificate warning if you've trusted the CA certificate. And this is the domain certificate you should get as a result. So for the domain here, and issued by the CA given to you here. If you look inside your domain certificate, you will see the number of requirements that I listed over here. For instance, we said that we need to have SHA-384 as a signature algorithm for an ECDSA public key. You will be able to see the public key over here, and this is the underlying curve. Okay, so it has two names, either P384, otherwise known as SECP384R1. That's the same thing. The certificate should include the SKI and the AKI. It should include the CA false bit as a critical extension. It should include a digital signature as a key usage, marked also as critical. The extended key usage should be for web server authentication. The domain also will appear both here as a common name and down there as a subject alternative name. And this is the signature of the certificate. Let's see a simple demo of our chat application. First, you will need to deploy the Docker container using the following line, which is given to you. You will first unzip the whole contents of the Docker image, and using Docker Compose, simply do Docker Compose up-d. It will take some time to compile the Docker container, and then once it's running, you should be able to access the application. So far, the chat app works only over plain HTTP, and the port is 8080. You will need to access it over, for example, this link for group 0. Remember that once you implement HTTPS, the port you should use should be 8443. Now open a new private window of your browser and browse again to this same link so that you have one instance in the normal browsing modes and another instance in the private window. This is useful so that you can access twice the same website and log in as two different users. So on the first window, log in as Alice, password is password123. On the private window, log in as Bob with password 456. You will be able to select the contact with which you want to talk. For example, Alice can select Bob and Bob can select Alice. Once that's done, the chat app will fetch every second new messages. You can start sending messages between each other. When you will modify the application, whether it's from the server side within the app.py or from the client side, simply restart the Docker container to make the changes effective. You do not need to rebuild the container, you simply need to restart it. The code for the application is mapped inside the container, and so a change in any of the files will be reflected instantly in the container. You simply need to restart it so that the server side fetches the new files. Let's see a demo of that. Here is our application loaded on the left in the normal browsing mode and on the right in the private browsing mode. You can see I'm accessing the website over the suggested URL. I'm going to log in here as Alice, password123. Oops, invalid. Alice, password123. Okay, we're in. Same thing here, I'm going to log in as Bob with password 456. Alright, great. We do have our chat app loaded for two different users. Alice can choose to talk to Bob, while Bob can choose to talk to Alice. Alice is going to send hello Bob. You can use Control-Enter to send messages quickly. And you can see the message appears on the other window. Bob can reply, which also appears on Alice's side. Alright, so you will have the refresh keys button to implement. As we discussed, you need to rederive new keys from the key exchange. The key exchange needs to happen before messages are eventually exchanged. That will be for you to implement. For simplicity, there is also an erase chat feature. If you click on erase, you will be able to entirely erase the message from the database. And if you refresh the page on the other side, it will also be gone. So you may use this feature as part of implementing your application so that you can restart from a fresh chat. And finally, you can log out. Let's talk now about how you get evaluated. You will need to submit a PDF report that includes explanations of your solution and design. That will be worth 50% of your project grade. You should provide the list of features and requirements that you have implemented. You need also to describe how your solution works, especially explain how user passwords are stored, verified, which libraries do you use throughout your project. You may need to use several libraries. How key materials are derived. How do you store them, their size, how do you generate domain certificates, and everything else which is needed for you in this project. You should show autonomy and creativity when requirements allow. That means whenever there is no strict requirements for something, you need to demonstrate proper judgment, and you'll be rewarded for any creative features or tasks. Second, you will also receive 50% of the mark on the implementation of your solution and the demo that you give. Follow proper coding style, write informative comments, give concise and relevant variable names, respect indentations, stay consistent in style, etc. We need to have quality coding. Make things work. If things don't work, you will not receive points. As many things that you are able to make work, and according to my specifications, the better. The submission requirement is as follows. You will need to submit a single zip file. This zip file should contain the modified chat application, which should work using a simple Docker Compose up-d. So Docker should be able to make your Docker Compose stack work. If there's a problem at that point, it's already not good. You are able to test it. Docker is designed so that if it works on your machine, it should also work on our machines. Once Docker is up, it should be reachable from that given URL, considering group-something maps to your group number as you have registered on Blackboard. The certificate received on this website should be a valid certificate given the CA that we gave you. The zip file needs to also contain the PDF report and an 8-minute video with a demonstration of your solution. This video can be done by any group members, and it should include a demonstration of the user registration process, chatting with a new with another user from a new chat, as well as refreshing the web page to see messages being reloaded. You need to also include a statement of individual contributions. Who did what? How much percentage of the work does that represent? For a group of 5 students, for equal amount of work, that should be 20% each. The format of this individual contribution statement will be given to you a bit later. Last but not least, the deadline for this project is in 5 weeks. You will have until Sunday, April 14th, before midnight, to send your project. Good luck!